So in algebra we have a lot of little crazy rules of things that can and can't be in order for simplify. So there's another rule. We already talked about a couple rules with radicals, but with a fraction or with dividing, there is a rule that says that you can't have an imaginary number in the denominator. And this rule kind of stems from this other rule that we follow, which means we can't have a radical in the denominator. So remember that I is the same as the square root of -1. So if I'm looking here, this is 9 plus 12i over 3 square root of -1. These are exactly the same thing. That's why I cannot be in the denominator, because it's actually a radical, which means we have to figure out how to get rid of it. So we're going to make an equivalent fraction. So I'm just going to write a little notation here, and I'd like for you to write the same thing. We're going to make an equivalent fraction. So what does that mean? That means we must multiply by 1. Because if we multiply by 1, it does not change the value of our fraction. However, our number 1 has to look special. So it's going to be a special looking number 1. Okay? So if we remember, number 1 can be 2 over 2, it can be 3 over 3, and it can also be 3i over 3i. So I'm picking 3i for a reason, and I'm going to show you in just a second. So I have 9 plus 12i divided by 3i. I want you to group this numerator because that's one number in the numerator. Okay? Now I'm going to go ahead and I'm going to multiply this funny looking number by the number 1, but my number 1 is going to be equally funny looking. It's going to be 3i over 3i. Pretty much whatever I see in the denominator is what I'm going to multiply by. Okay? And the reason I'm going to do this is because 3i times 3i, let's do this over here, 3i times 3i is going to give me 9i squared, which is going to give me -9. So remember, you can always do this in your calculator so you don't feel like you're going to mess up. So if I do 3i times 3i, I get -9. Okay? So that means here my denominator is -9, which is perfectly fine. And then in my numerator I have, I'm just going to write this on this side because most of us are more comfortable with that. Okay, so I can still simplify this, and I'm going to use my calculator. So I'm going to do 3i parentheses 9 plus, now remember these are multiplying, okay, 12i, that's one reason why I'm using my calculator, so I will limit the number of mistakes I have. So that's going to give me -36 plus 27i all over -9. Okay, so there's one more thing I want to show you here because you may not see this on an SOL. So I'm actually going to factor out a negative in the numerator. So I have a negative. If I divide -36 by -1, I get 36. If I divide 27i by a negative, I'm going to get negative 27i. Notice how I just changed the signs. And this is still negative 9. So what I want to point out here is negative divided by negative gives you a positive. Notice that I can only do it after I have divided that negative out from my grouping. Okay? And then that gives me my final answer of 36 minus 27i all over 9. So that's my final answer there. Okay, I have one more problem I want to do, and I'm just going to make it quick and easy as I can. So here's my other problem. 2 plus 3i divided by 1 minus 4i. So the first thing I want to make sure is that I realize these are each one number. So I have to get this I out of the denominator, but this is one number. So there's a little trick. Yes, I'm going to multiply by the number 1, but my number 1 is going to look very special. It's going to be what's called the conjugate. I'm going to write this out. Conjugate. So the conjugate of 1 minus 4i is 1 plus 4i. So notice how those signs are different. So what I do on the bottom, I do on the top. Okay? So I'm going to make this easy for myself, and I am going to use the calculator. So I'm going to do it like this. Let's do the denominator first. So I'm going to do parentheses 1 minus 4i times 1 plus 4i. That's my denominator. I get 17. See how nice that is? So my denominator, I got 17. So let's do the numerator. Parentheses 2 plus 3i times 1 plus 4i, and I get negative 10 plus 11i. And that's my answer. That was pretty easy. So this is the simplification of this fraction here. So I want to talk about conjugates. So the conjugates, I'm going to put an s at the end. So here I have 1 minus 4i. My conjugate would be 1 plus 4i. So just as long as my signs are the opposite inside each binomial, in between my real and my imaginary, I have conjugates, and then I can work my problem out as such. Not too complicated once you know the trick.